Lab 4, Momentum and Kinetic Energy Conservation in Collisions. This lab, students explore physics involved in collisions, namely the momentum and energy conservation conditions we learned in class. Okay, these conservation laws will be demonstrated in both elastic and inelastic interactions. So the simulation are performed using the PhET lab platform, and where students will create various collision scenarios and observe their outcomes. The initial velocities and final velocities and computed momentum and the kinetic energies are recorded in the data table, and as they are analyzed, checked against their speculations. In fact, you just start from here, and PhET lab, you click the link and you start. You're ready to do the experiment. Click one dimensional. So you have basically different balls and with different mass, and you want to click this data, show the more data. So you can make all kind of collision scenarios. First, you will consider, let's give it a try. So here you can say mass 1. You double click it, you will say 0.5 kilograms. So 0.5, for example, and enter. So the other one, 0.15. The velocity, and we take the right hand side to the right to be our positive direction. So for example, in this case, you will just velocity say 1 meter per second. Okay, and you can say 1. So then you see here become 1. And on this side it was negative 0.5 as a negative 0.5. So, and then you can hit this button to do the simulation. Basically, what we want to see is the velocity change. What will be the outcome of this interaction? So click, go, collide, and stop. And then you see before the collision, you write down all these numbers. And after the collision, the velocity changes, and then you will record these numbers again. Final velocity, and in this case, both of these objects change directions. You have a choice of elastic collision, where the total energy and moment as well as the momentum are conserved. And you can also choose inelastic, basically how many percent of energy is retained or kept. Okay, so if you put 0, which means totally lost, okay, in the collision, and of course then you have 100% elastic, like a perfect spring. And we'll do two cases. One for cases for a number of cases for elastic, and then we'll do a few cases with inelastic. All right, let me show. So that first you just play with this for a few times. Important is you can show more data. So you show more data, and you click the kinetic energy, it will be calculated over here. We talked about how do we calculate the kinetic energy in the class. Basically half of mv squared. You just have to do your calculation, but it is calculated here. Well, momentum is also calculated for each individual one, but you want to record the total momentum, you simply have to add this together, because we'll see if the total momentum is conserved, even though each individual momentum may change drastically, but the total is a constant. So that's, you play with this, see if you're satisfied with, understand what's going on. Let me do again. So of course, also we have this additional information. It can also collide with the walls, but we probably don't concern this fact. We may do another experiment to come. So we basically what we do, you click here to reset, and so then you say okay. Then you click this to be negative, say 2. So there will be -2, and then this will be positive 2, negative 2. So hold on. See, I set the velocity of the first one to be 1, and I set the velocity 2 to make them head-on collision with different velocities, and say 0.5. So never negative 5, but then 0.5. Click. You can click this. I'm sure you know how to do this. So here 0.5. Enter. So see 0.5. So then of course you can put them at different position. In our case, we probably don't care where it is located because we're supposed to be energy is conserved, supposed to be perfectly smooth. So now once you have ready, so you click this and see you write down all these numbers in the chart, and then go, stop, and then see in this collision, so they will go slowly that way and change the direction. You write that, so the number changes. Okay. Total kinetic energy is already calculated here, but if you can calculate yourself, just half mv square of this plus half mv square of this, and then you press the calculator, then you will get this total. But momentum is not calculated, but you can add the total momentum together. In this case, it's negative something, but then it will be, you have to enter them in the table. So play with this, see if you understand everything, and of course you can replay in every case. Okay, you can replay, so you can replay as many times as you want. Boom, stop, and then to write down the numbers. So after brief introduction, here comes to what you actually do. So I will put this table. You will do 3 cases of, or 5 actually. In here I will change to 5 case, actually 5 cases of elastic collision. Recorded data in the chart below. Actually this is a sample, and yours will give you similar, and then with all the data removed. But I will remove all this, and of course this will be available in this video if you watch this video. So for example, the first one, you choose one large collide with a small, and you set one at kilogram, 3 kilogram, the other one at 0.1. So this one is large, that one is small, and both have same velocity, which means they are traveling against each other. The momentum, you calculate the total, you calculate here, and then you will do, okay, you do this case, and you hit the button, it will get a collision, and then you write down all this here. So you're done with it. But while you're doing this, I want you to make a short video and link it here. So see like what I do. So you click here, and then you will see okay, you put your video, click. So this row, what you will get is this one.
Large and small collision.
Yeah, and you have a video. I have a video. So then you write down this neighbor. So that's this one.
That's
one, you have a small one bump into a large one, but with the large one at rest. So if you click this and you want to take a video and to take this data, and you have a lot of things to do. So you click this
into a large one, and it has initial
small one
velocity,
right into a large
is
one.
at rest. See the velocity set of 0. Go.
You complete all these 5 cases. Every time you get this data before collision, after collision, and do the calculation, and then you take a video and make a link over here, and then you're done. And so I did all this, and then you will do answer all these questions, and then you will move on to another kind of collision. Is inelastic. So inelastic. So it's the same setup, but so initial and final is set up, and then I already done the first one. For example, this one. Let's see.
Now let's work on the inelastic collision. there, which
So that's
means there is
inelastic.
energy lost. If you
Yeah, you
set
set
this
to
up at
50% energy
loss here, and
then of course
and then
the
we just
initial
try the
condition
same
is the same,
cases,
but then you will figure out
same
these.
mass, same initial speed, the large and small. We try the first case. So I have set up here, and then over here. So inelastic case, first case. Now you see, and they are head-on collision with the same speed, positive and negative. But now, because there's an energy loss, the result will be different. Starting condition will be the same. Now let's see. Go. Boom. You see? Okay, you see there's energy transfer, looks similar, but the energy, total energy is less with 0.09.
So that's the inelastic and elastic. You could, if for the convenience, you could do the other way. It's up to you. You can do, because the setup, you don't have to change the setup. You do a large and small setup, elastic, and change to inelastic, get this row. Of course, you have to take the video. And then you go to small, run into a large with large at rest. And then do this elastic and switch to inelastic, do the same, filling up this. So, well, some work. It would take like half an hour or so. That's what I did, and getting you familiar with all these collision scenarios. All right, hope this is helpful, and I'm always available if you can talk to me through Zoom or in class. All right, bye for now.